Okay, one of the main reasons as to why there was a debate about who invented calculus was because both Newton and Leibniz, it's on your textbook if you have a look, both of them were studying calculus in a different form. Now, Newton specifically back then had to solve equations which sometimes couldn't be differentiated or easily worked out. One of them was the original sine function. Did you guys know what the sine function was back then? Assuming I remember it correctly. Are you ready? The original sine function from memory is x plus x cubed over 3 minus x to the power 5 over 5 plus x to the power 7 over 7, etc. I think the signs are the wrong way around. Yeah, I think it's that. Now, if you're trying to solve something like that, where it's equal to 0, and this function keeps going, it doesn't stop, you would have a lot of trouble solving it, wouldn't you? Yeah. Because you'd have to actually try and factorize each and every single one of these terms. The higher the power it is, the harder it is to work out. So, Newton went, no, this is not a great way to do it. So, to find all the roots, or to solve for all the different answers that you have on a graph, what he did was he rearranged the original equation here of a tangent. Then he said, if we want to find the next x value, we can rearrange it so that we get this form. Because we're trying to find where y is equal to 0, you can actually try it yourself. You just make that a 0, then you just rearrange it here. Okay, I'm not going to go through the steps. You can have a look on the textbook. It's all on there. Now, just to go through what this is, if you're doing general maths, you might know this. It's a sequence or a series. Do you guys remember doing series? Yeah? This is a series where the next x value is equivalent to the previous x value, where you have the previous points and the derivative. Now it sounds a little bit weird that we can actually find the points and derivative, but your CAS does similar things to work this out, and you also have quite often you actually have the points and derivative of each, but you can't find the actual function. That's the reason why. Just to show you this program, you'll get it in a second, don't worry. I made it in eActivity. There you go, Newton-Raphson method, written all right down how you do it. All you literally have to do is write down two things, your function and your starting point. So let's say you had something like something hard to solve, like x to the power of 3 minus x squared plus 5x minus 1 or something. Nope. Let's write it with x squared. Ah, right. Of course it doesn't work. Equals x to the power 3. Now, if you write an equal sign, have any of you used Excel before? Yeah. It's really similar to Excel. If you write in an equal sign in front of it, like I have here, the equal sign tells us that it's a function that we want the CAS to remember. By putting that in, and we put in a starting value, we can actually try and find the point. Don't stress, you don't need to do anything. All you have to do is keep reading down here. See how the values stabilize around here? That's your root. In other words, that's your that's the x value in which y will be equal to 0. So all you have to do is read this value here, and it will tell you how many decimal places it is. The reason why we do that is because there's no exact value. Any questions with it? Is it fairly straightforward? All you literally have to do in a second is grab the program off me and just type it in. I've made it really simple.